Section 4.7 again deals with CPCTC, but now we will start using it to help us do some more complicated, a little bit longer proofs. So we won't just stop after we've proved triangles are congruent and then just using CPCTC as the last step anymore. So before we get into the proofs, I'd like you to practice doing this. This is something we have talked about in the past, where if you have triangles that are overlapping, it's a good skill to have to be able to pull them apart and redraw them as separate triangles. So I'd like you to do that right now. And then once you've done that, identify the common angle. What full angle do these two triangles share? So the picture that you could have drawn, notice I just, if you can imagine, just literally pulling them apart, separating them, and then relabeling each vertex. I didn't turn them at all. I kept them oriented the exact same way as they were in that original picture. Now these two have in common the angle G, or if you named it angle DGE, EGD, something like that, it's the same idea. So now, if we move on to our next example, this proof, this would be a proof that I would suspect most of us would probably be pretty successful with at this point, because really it's not all that complicated of a proof. What makes it kind of interesting, potentially, is the fact that your triangles are overlapping. So notice I have these marked up, but what I want you to notice here, more than anything else, is that it is possible for you to take these two triangles and separate them. Make sure you completely label the vertices again, but then that might be something that helps you when you go through and do these proofs on your own. So if we were to do this proof, we'd have our two sets of congruent angles as our given information. And then whether we tell from the original picture or we tell from the two individual pictures that we've redrawn, we would have to be able to see that segment WX is a shared side. So we would use the reflexive property. This is the old way that I used to have students write it. So we would write this as reflexive for our reason. Now we would be able to say that those two triangles are congruent to each other by angle side angle. Make sure that your congruence statement of these two triangles has the vertices, the corresponding vertices, in the same order. And then lastly, we can say that segment ZW is congruent to segment YX by CPCTC. So that's an example of a proof that we've already taken care of in a previous section. Our next proof, notice it's a little different for us yet again. We already have the triangles being congruent to each other. This time we're trying to prove we have segment CE congruent to segment DE. But the key to this proof is you have to notice that segment CE and segment DE are not full side lengths of the triangles that we have already given as congruent. They're only parts of those side lengths. So we can't go ahead and use CPCTC to say that those are congruent segments. We have to find another way of saying that. So starting off our proof with our given as always. But now, if I just take a moment and I look at this picture, if I look at where segment CE and segment DE are, they're intersecting at point E, making a triangle down here in the bottom part of this given rectangle. And if I want to say that those two sides of that triangle are congruent, I'm basically trying to say that that's an isosceles triangle. So earlier this chapter, we had a theorem. It's actually the converse of a theorem that said if you can prove that the two base angles of a triangle are congruent, you can say that it's the sides opposite from those angles are congruent. So here, if I'm able to say that angles ADC and BCD are congruent to each other, which we can by CPCTC, we can say that segment CE is congruent to segment DE. What's the reason that we would have to use for this? The reason that we can say segment CE is congruent to segment DE is the converse of the isosceles triangle theorem. So how we're writing this, it's a little different than in the past. The converse of the isosceles triangle theorem. There we go. Now with the proof in number 4, we really start to get into what this section is all about. So here we have a diagram that has numerous pairs of triangles in it, and we are supposed to specifically prove that triangle GED is congruent to triangle JEB. So if I have a diagram that looks like this, the first thing that I'm going to do is I'm going to separate the two triangles that I am trying to prove are congruent. Now when I do that, when I redraw them, I have to make sure I relabel all the vertices so that I have the correct points when I'm dealing with the rest of this proof. So now once I've drawn that picture, I can go ahead and start my proof by saying that E is the midpoint of segments AC and DB. That's our given information. Now when I go and show that in my picture, I'm not only going to show it in the original picture. Actually, rewind a second. We really can't say we can't make any markings based on that statement. We first have to say that we have congruent segments by the definition of midpoint. Got a little ahead of myself there. Sorry about that. Now we can come in here and show that we have specific congruent segments. But not only should we put those in the original picture, we should also put them in any picture that we've redrawn. So now I can have segment DE is congruent to segment EB in both of those pictures. From here, if I'm trying to get these two triangles down here underneath my original picture to be congruent, the next thing that I'm going to need to say would be that I have a pair of vertical angles that are congruent. So if I'm naming those vertical angles, I'm going to call that angle GED is congruent to angle JEB. And again, not only should I mark that in the triangles that I have pulled out and redrawn, I should be marking that in the original as well. Now we run into the issue of not being able to say anything else about the two triangles that we are trying to prove are congruent. So what we have to start doing at this point is looking back at our original picture and seeing if there's another pair of triangles we could prove are congruent. Well, looking at this picture, I can see that I have a second pair of triangles where I already have two sides congruent to each other. So if I pull those out and redraw those, and this does take some practice to be able to see which triangles you'd want to be dealing with. That's why it's so important that we actually do the practice. We have these two triangles, AED and CEB, But not only can we redraw those triangles, we can also pull out these marks with them of these congruent sides that we had in the original picture. So if I want to get those two triangles to be congruent, I would also have to say that I have some vertical angles here that are congruent. So I can mark those both in the original picture and in this new one I just redrew. And now, whether I write it as a new step or I include that new pair of vertical angles in my already written vertical angle step, doesn't make a difference. So here we could have the add to the statement 3 that angle AED is congruent to angle BEC because those are also vertical angles. From there, I have enough to say that the second pair of triangles is congruent. This thing's really not cooperating today. Sorry, guys. So we can say that triangle AED is congruent to triangle BEC by side angle side. And the way that that is beneficial is because triangle AED and triangle BEC have some common parts with triangle GED and triangle JEB. So now the trick is to be able to identify what those parts are. Okay, we need to be able to tell that angle D and angle B are both angles, full angles that are the exact same in both of those pairs of triangles. So we want to use CPCTC to say that those are congruent to each other. So we've got angle B congruent here to angle D. Also have that in the two triangles that I'm trying to prove congruent, and that came from these two triangles down here that I've already proven congruent. So now looking at the picture of the two triangles that I'm ultimately trying to prove congruent, we would have enough to now say that they are congruent by angle side angle. So it's only a 6-step proof, which is not the longest proof that we've done so far this year. But there is a lot involved in that, a lot of things that you have to look for now with the overlapping triangles and needing to use CPCTC to find more parts that you can use to ultimately prove what it is you're trying to prove. In the fifth example, we have another proof that's going to involve multiple pairs of triangles being pulled out of the original diagram and needing to use CPCTC to find the correct information to ultimately prove triangles are congruent so that we can, in this case, prove a pair of segments congruent at the end. So, as always, no surprise here. Start out with your given information. So let's see, I need to show that given information in my proof. So if CA is congruent to CE, these two full sides here are congruent to each other. And BA, segment BA is congruent to segment DE. So we have those. So now, I'll take a moment before I write anything else and I actually look at this. If I'm trying to prove that segment BX is congruent to segment DX, okay, I need to realize that at the end of the proof, I'm going to need to use CPCTC. So that means I have to get a pair of triangles congruent that have those two segments as sides. So looking at my diagram, the two triangles that have BX and DX as sides would be the triangles BXA and DXE. So that is a pair of triangles that I'm going to redraw and relabel to make this a little easier to see. And don't forget, when you pull those apart and redraw them, you need to bring any marks with them that we already have. So we have AB and ED being congruent segments. So now, like I said, these are the two triangles that we need to get congruent. Is there anything else we can say at this point to get us closer to saying they're congruent? Well, we could say that we have angle AXB congruent to angle EXD by the vertical angle theorem. So we have congruent angles, mark them in both the original and the new picture. But now we run into an issue. We don't have another thing that we can say for another pair of congruent sides, another pair of congruent angles. So we have to, again, look elsewhere. Is there another pair of angles that have some parts in, triangles, excuse me, that have some parts in common with the two that we've already redrawn? In this case, those two triangles that we would need to realize and then redraw would be triangle ADE and triangle ABE. So if I have those two triangles redrawn now, here we have to make sure we take the information with from that original picture. So now whether you're looking at the original picture or looking at the new pictures that you've drawn, what else can you say about those two new triangles to get them closer to being able to be proven congruent? Okay, we'd have to use the reflexive property. AE is a shared or common side, so we can show that those would be congruent to each other. And now, here's the key one that some people would miss more often than they might miss something else. We have to go all the way back to our original given information, the fact that segment CA is congruent to segment CE. This whole triangle, ACE, is an isosceles triangle. So that lets us use the isosceles triangle theorem to get a pair of congruent angles. So we'd have angle CAE congruent to angle CEA, which happen to be the included angles in the second pair of triangles that we're trying to prove are congruent. So now looking at our diagram that we've redrawn, we can say that triangle BAE and triangle DEA are congruent by side angle side. Again, just a reminder, make sure your congruent statement has the corresponding vertices in the same order. So now we have to look at the two triangles that we just proved to be congruent and try to realize which parts of those two triangles do they have in common with the two triangles that we ultimately need to prove are congruent, and those are triangles ABX and EDX. So what they do have in common is a pair of angles. Angle ABE, so if I mark that in the triangles I know are congruent, ABE would be this one. The reason I have to name it ABE is so that I can also see it in the other picture. And then EDA in both. If I mark those, we could now say that angle ABX and triangle ABX and triangle EDX, excuse me, are congruent by angle side. And then as soon as we have those triangles congruent, we can wrap up our proof by saying segment BX is congruent to segment DX by CPCTC. So this is where we're going to stop. Please do not work on the last proof on your note sheet at all. We are going to take care of that together. So that needs to remain blank, please.